It's SCi time for grade 7 students, and this is the last part of the 14th lesson, heat and temperature lesson. And let's see what we have done so far and today's plan. And 14.1 measuring temperature part we have completed, and 14.2 thermometers part completed. 14.3 heat transfer we will do this today, and also 14.4 applications of conventional currents we can complete today. Then let's move on to the heat transfer chapter. Look at these pictures. The picture shows how heat travel from the heat source to somewhere else. If heat traveling from one place to another place, that's called heat transfer. There are different ways of heat transfer here. First of all, let's see this. Traveling of heat from one place to another place is called the heat transfer. And what are the methods of heat transfer? If you observe this one, there is a person who's holding metallic stick over this fire. When the metallic stick heating up here, the heat travels through the metal stick. This method is called conduction method of heat transfer. And if somebody keep the hand just above the heat source or just above this fire, then heat travels through the gas. If heat travels through gases or liquids like this is called convection. And this is the second method of heat transfer. Also, if you stand nearby the fire or nearby a heat source, heat travels across, or it comes to our body like this as the third one. And this method is called radiation. Therefore, there are three methods to be discussed. One is the conduction method of heat transfer, convection of heat transfer, and the radiation method of heat transfer. Look at this video, and this is the method of heat transfer through solid substance. This is the activity number 3 given in the tube. What are the materials needed? And let's play the video and see them. A candle we need, and shoe tack nails or small nails here, and a wooden stand here. Also hacksaw blade made of metals. Here's the method. We fix that hacksaw blade to the wooden plank with a nail like this. Thereafter, by pouring some wax drops, we fix these nails on the hacksaw blade. So there are 5 nails that we fixed with certain intervals or certain gaps. Now it's ready to observe what happens here. When we keep this candle under the metal plate here, and if heat travels here, look at the observation. You can see when it's traveling through that one, these nails, the wax melting and nails falling down. The first one has already fallen down. This is the second. That means heat has traveled to this place. Now further it's heating, and now the third one is just merely to fallen down. Yes, it has fallen down then. And likewise heat travels slowly through the solid. And the fourth one has already fallen down now. And this is the fifth one. If heat reach here, wax will melt and the nail fell down like this. So this is the observation of the activity. Through that one we can say the heat transfer, the heat travel through a solid. It's gradually in a way of gradient, it's gradually travel through this one. So this is the method of heat transfer through a solid substance. This method is called conduction method of heat transfer. Now let's see how that heat traveled through this solid. And thermal conduction method. Imagine you can see these particles of the metal, and this video shows that how the metal particles support this heat transfer. If you see this, the Bunsen burner heating up the metal. Can you see there are particles? These tiny particles are the solid particles. Remember, the solid particles can't travel through the solid. Only thing happen here, the solid particles start to vibrate. This vibration carries the heat from one particle to another particle. Therefore, from a particle to particle it travels. And this is the method of heat transfer through a solid. This method is called thermal conduction method. And this is how heat travels through a solid. Thermal conduction. You can see the heat transfer. This whitish color increase traveling means heat travels or transfer through the solid. And then this occurs only in solids. Remember, the conduction occurs only in solids, and heat passes from particle to particle without the motion of particles. Particles do not travel, only the heat energy transfer through this. Now let's move to the next part, thermal conduction, and these are the good thermal conductors, like all the metallic things: brass, aluminium, cast iron, bronze, metal sludge, and the steel, copper, all are metallic things. They are good conductors of heat. Therefore, we call them thermal conductors. What are thermal conductors? They are the substances that pass thermal energy easily through them, are the thermal conductors. And all the metals are good conductors. Next, look at this set: glass, plastic, ceramic, rubber, wood, fabric, paper, cork, wool. These things are poor thermal conductors. And imagine such case here: if uh, there is a cooking utensil, we make cooking utensils with a metal. But when we make the handle of the cooking utensil, we make this handle with a poor thermal conductor, such as plastic or wood or such thing. We make this handle because we need to reduce the heat transfer to our hands. But the cooking utensil is made of aluminium or copper or something, because through the metals heat transfer well to the food very easily. This is how we manage these thermal conductors and insulators. Now let's see what are the thermal insulators. Thermal insulators are the substances that do not pass heat well. They are the thermal insulators. Do not pass heat well. And most of glass, wood, plastic, cloth, they are water, they are thermal insulators. Right, now it's time to move on to the activity number 4 in the tube: convection through gases and convection box here. This is called the convection box. And let's describe what happens here while playing the video. And here there is a candle here lighted up in a box. There are two chimneys here. One chimney is just placed over the candle. This chimney is directly placed over the candle, and when candle is heated up, the heat can travel through this chimney here. And we light up the smoke source here and let the smoke to enter into this box. Usually smoke goes up here. Now it is closing here with the glass here. Thereafter we light up the smoke source and letting it to travel. So this is how we light up this and keeping it here. You can see the smoke very rapidly drags into the smoke box, and normally smoke goes up, but here it's taken in. Thereafter, as the heat travels, as the heat received by this part, and the smoke can be observed coming out from here. You can notice the smoke is now coming out from this chimney like this, and it is due to the convection. Let's stop it and explain it a bit. This is what happened. This heat, when the heat coming from the candle, the density of air decreases. That air or that gas particles or smoke particles goes up then. To fill this space, smoke comes from this chimney here. And in this convection method of heat transfer, particles travel. Here these particles are gas particles. Gas particles travel from higher hot area to the less hot area, or hot area to cold area. And this is the method of heat transfer. In this heat transfer, particles move and particles travel. This is the heat convection through gases. Next one is about convection through liquids. Convection through liquids. Look at this experiment, watch this out as well. Here we have round bottom flask, tripod stand, and condensed crystals here, also a split lamp. Round bottom flask with water, it is kept over this tripod stand. And next thing is taking condensed crystal. One crystal we can place or put into this one like that. Now the condensed crystal, we have to wait until it settles down to the bottom. Once the condensed comes to the bottom of this round bottom flask, then we can keep the split lamp under this. Now we can keep this split lamp under that. So thereafter we can light up the split lamp, or our heat source we can light up with the lighter and lighting this up. Then let's notice what happens. Heat is coming from the split lamp to the bottom of this round bottom flask. Yeah, there's water in this. Now you can see that colored particles starting to rise up. As I mentioned, hot particles goes up. This is the convection. And again cold particles settle or descend down. They are descending down. Hot particles ascend, cold particles descend. This is the convection through liquids. In convection, particles directly move. And see this here, with that animation we can understand this convection currents. When heat is received, the hot particles going up like this, and the cold particles coming down. This whitish area are the very hot area, the bluish areas are the cold areas. And likewise it circulate like this. This motion or this traveling of the heat or the hot particles and cold particles like that, this is called convection currents. Convection currents. And the heated liquid or gas move upward, and cold liquid or gas move downwards. Hot ones goes up, cold ones move down. When warm liquid gas reach the top and cool down, again they move down. They move down again, or that means the when it go up, when after cooling down they comes down. So this movement of particles is called convection currents. Remember, this is convection currents. And convection occurs through fluids. Fluids means liquids or gases. It doesn't take place through solids. And this is the second method of heat transfer, convection method. Now let's see two applications of convection. Sea breeze is one application. Look at this picture. This is sea breeze. It occurs at daytime. Here there is the sea and the land. The reason for the sea breeze is the land getting warmer quicker than the ocean. That means in daytime, land takes short time to heat up, but the sea takes long time to heat up. Therefore, the air nearby the land rise up, because when land gets heated, then the air particles get heated. Hot air particles goes up. there will be a blank space here or empty space. To fill up this space, wind blows from sea to the land. That's why we call this sea breeze. Remember, it occurs at daytime as the land heats up. When air goes up to fill that space, air comes from the ocean. Then sea breeze take place. Therefore, the ones who are traveling in the rafting boats, then the boats will come towards the land in daytime as the wind blows towards the land. Sea breeze. And what is the land breeze then? Land breeze. This is occur at night time. At night time, the hot ocean take long time to cool down, but the land cooling down earlier or very fast. Therefore, at this moment, land is colder than the ocean. As the ocean is hot, air nearby the ocean rise up by the convection. To fill this space, now this time, wind blows from land to the sea. Therefore, at night, wind blows from land towards the sea. So most of fishermen traveling or the going into the ocean at the evening or night time because their boats are easily carried with the breeze. This is the land breeze. Both of these phenomena occur due to the convection occur through the gases. Now activity number 6 about heat radiation. Look at this activity. This cube is called Leslie's cube. It has different surfaces: shiny surface, white surface, and black surface. Let's check this out. First, we must fill warm water to this. Then warm water, once it's filled, then we can see how heat comes out from these surfaces. The heat radiation method. This is a infrared thermometer. These thermometers are very popular nowadays. And first they are measuring the temperature of this surface. It is the white surface here. What is the temperature? It's 49.8 on white wall or the white surface, and heat radiated for about 49.8 degrees Celsius. Then turning this to the shiny side. Now guess what will happen to the reading? Will that be increased or decreased than the previous one 49 when it was the white color surface? This is silver color surface. See the value. The value is 27.3 this time. Lesser value. That means the heat radiated in less amount in the shiny surfaces. And finally we can move on to the black one, black surface here. Again guess. Will that be greater or lesser than the previous two? See the value. This time that's going to 68.0 degrees Celsius. That means the highest emission or the highest radiation of heat take place through the black surfaces. Least radiation take place through silver surfaces, and highest through the black surfaces. The special fact about the heat radiation, it doesn't need media to occur. Heat travels as waves in this case. With the next animation we can explain it. Here's the explanation for heat radiation. Taking a metal and heating by holding directly over the flame here. Now that hot object keep in nearby the cold one. Heat travels as waves in this case. Traveling as waves. For these waves to travel, a medium is not necessary, but they can travel through solid, gases, air, or without medium. That means even in a space, heat can travel like this. The heat coming from the sun to our earth by this method, because between the sun and the earth there is no medium, or it is just space only, but the heat rays traveling through the sun to us by this radiation method. That's the third method of heat transfer, heat radiation. See the facts. Radiation occurs due to the transfer of rays emitted from hot objects. Rays traveling here, heat rays. And this means that the thermal energy transferred by the radiation can even work in space, even in a vacuum that can be take place. With that one, we mark the end of this lesson. We learned three methods of heat transfer today: conduction, convection, and radiation. And you can find out the notes now from the blog site www.itscitimblogspot.com. And our next lesson is the unit number 15, the soil lesson. If you gain or enjoy this lesson, and just press the like button. Also, if you haven't subscribed the channel yet, subscribe it. Also, to get the notifications, press the bell icon. And we can meet from the next lesson, the soil unit, the next week. Goodbye everybody.